They're coming in now, Tally. So
Oh, hello.
let them know. Well, I think they're still coming in. So give it a minute and then.
Okay. Also, I'm realizing I can't see my cursor. Can you guys see my cursor?
No.
Okay, let me, Anna, do you remember the trick for that or not?
Yeah, there's a keynote setting in the keynote preferences.
Keynote setting. No, that's Zoom. All right, hang on a second. Welcome everybody. By the way, we're just going to wait a couple minutes to get. We are looking at the number of participants and registered and waiting just a minute. So hang in there. Also, I'm trying to figure out how to get my cursor. Display preferences? No, that's not it.
You're in the right window. Go, it's that show pointer, that one, yeah.
Lovely. Thank you.
We've got 48 tallies, so maybe okay. 48 people, 49. Maybe give it a couple more minutes.
Okay. It's nice to see some of your names, and it's been a while. I hope you're all doing well. Yeah, I'm not too worried about time. I have probably about let's see, I have 50 slides or so, that some of which are really fast, and we have an hour and a half. So I do intend for this to be question heavy. I would like for it to be question heavy. I mean, I feel like that's usually more useful. So I intentionally kind of left it at less than an hour and a half. So maybe in 1 minute, what are we up to here? Yeah, they're trickling in. I feel like we're probably not gaining too rapidly at this point. So, of course. Yes, the recording will be available. In fact, we're already recording, right?
Yes.
We're going to make it available on our website for a limited period of time for you to watch on our website. So if you are interested in rewatching it, it's not for general distribution, as we'll explain. If you email us and ask us for the password and the link, we will send it to you.
Yeah, and I would like it to be up at least until the next, we do have other Python lectures planned, and so I think it'd be nice to have it up there at least until the next one, just so, because there's, hopefully some amount of continuation. All right, I'm gonna get going because I think our rate of increase is decreasing. All right, welcome all. This is a bit of an experiment. Normally we talk about microscopes, and I wanted to talk a little bit about Python. So for those of you who don't know me, I'm Talley. I'm a lecturer in systems biology, and I work in the Nikon Imaging Center and cell biology microscopy facility. I do a lot of Python. I've been using Python maybe 10 plus years, and in the last 5 or 6 years quite heavily. I've done a lot of projects with it, like FPBase and some internal projects, and more recently I'm a core dev on Napari, an Python-based image visualization. So the reason I wanted to do this lecture first is, well, first of all, we sent out a query, and this was one of the biggest hits. I think getting set up with Python can be confusing. In contrast to like MATLAB, you download something and it's like this whole environment is ready for you. You just double click on it and there you are, you're in MATLAB. I think the what exactly Python is and what it means to set it up is confusing, just because there are many different ways to do it. you Google it, and there's 5 different things that say the right way to set up Python, and there is no one right way. I will give you some tips that I feel like are particularly relevant for data science, because that's what we're in. There's no code here. We're just talking about getting set up. So really the emphasis here is on virtual environments and installing packages. And absolutely, I love questions, so go ahead and put them in the chat. I will try to get to them, and then we can also talk at the end as well. So rough outline here. I just want to I know probably most of you who are coming to this have hopefully used Python a little bit, if not a lot. But I will just kind of reintroduce Python. I think it's useful to kind of just keep in mind how it compares to other languages and why we would even use it for certain things and why we might consider not using it for other things. Really what I want this lecture to be is just to define, what a Python interpreter is, what environments are, and what packages are. We'll go into using conda, the environment and package manager for managing virtual environments, as well as installing packages and what packages are and stuff, using pip. Very briefly, just talk about running code. That's really not the emphasis today. Just want to make sure that you are clear on the various entry points to actually executing some code. My cat is visiting. And then very briefly talk about integrated development environments, programs that you can use that kind of match maybe a MATLAB-like interface. I'm not talking about how to actually code in Python here. Some of the later lectures might talk a little bit about tips and tricks, but I'm honestly not that interested in super basic Python syntax, because I feel like there are some really good tutorials out there, like just, the Python documentation itself is excellent. Software carpentry is great. There are so many blogs like this, but I think Real Python is a decent one that's worth looking into. And then, of course, research computing here at HMS also gives training on Python with an eye specifically to using it on O2, the cluster. So check that out too. There's a slightly opinionated. I will, sort of direct you towards things that I think I see frequently used in data science. There's always many ways to do the same thing. So if you know of a different way and you like it, that's totally fine. This is maybe my personal preferences or recommendations to sort of weed through all of the many different options. If you're in any way confused, these are reasonable, sane starting points. Just to kind of put this all into context, why are we even talking about Python? Because it's so hot right now. Python is like all the rage in data science. If you look at a graph of Stack Overflow questions, so Stack Overflow is one of these online forums for general programming. And if you just look at the frequency of given tags, Python, Java, C++, over the last decade or so, you can see that Python in the orange here has just shot up relative to the other main scientific programming languages. It's dwarfing them at this point. And even if you look at literally all languages, it's kind of one of the more talked about languages out there at the moment, maybe close to JavaScript, but these are obviously different realms. JavaScript is huge in web development, and Python is huge in data science. And people like it. So, if you ask people what are languages that you use and would like to continue using, Python is right up at the top. Rust is a little higher, but that's really not for your average sort of quick data science, though it can absolutely be used for that too. So Python is popular, people like it. So what is it? It is an interpreted, this is the definition if you go to python.org, it's an interpreted, object-oriented, high-level programming language with dynamic semantics. So what the heck does that mean? Interpreted, this is a big part. Interpreted, this is sort of in contrast to a compiled language. So a compiled language would be something like C or C++. The borders here are a little bit fuzzy, so don't think of these as strict binary terms where one is all this and the other is all this. But generally speaking, when we talk about a compiled language, we're talking about something where, you know, you write your source code. The source code is this human readable code that has English language like stuff. You then use a compiler, like for C, it would be something like GCC, to turn that into machine code, binary code, zeros and ones that the CPU knows how to directly execute, right? This is like an assembly code that the CPU can execute. And so you need a different compiler for each type of platform, and you, the developer, need to compile your code into different, you know, a Mac version, a PC version, a Linux version before you ship it out. That's sort of compiled code, and a lot of error checking happens at compile time. Python, on the other hand, is often referred to as an interpreted language. So is MATLAB, for what it's worth. And this is where you write the source code in your English language like thing. And then really that is the thing you tend to ship. You ship your literal source code. You don't, there is no local compile step before you ship it. It does in the background get compiled when you run. So when you say, let's run this file, Python, the Python executable, Python program is going to parse that. It will then compile it into what's called bytecode. Sometimes you've seen these PYC files if you've run Python locally. This is the compiled bytecode, which is then run by Python itself to actually execute the program. And this Python interpreter, that is where you can get the sort of cross-platform thing, because the Python interpreter exists for Windows, Mac, Linux, etc. And so you, the developer, can just write your source code, ship the source code, and then as long as the end user has Python on their system, that Python interpreter can run that. And it really makes for, you know, super easy for you to do cross-platform development. It also makes rapid development because, you know, whereas in a compiled system like this, you have to compile the code every time you want to test it. On Python, there is a compilation step that happens in the background, but it's almost invisible to you. You just say Python run this file, and so it's super easy to iterate like that. The downside is in some cases it can be slower to execute than compiled languages, but we'll talk about that briefly. Object-oriented, I'm not going to really go into this. It means that you can create objects. Objects have attributes, and they have methods that run on those attributes. This is not the point of this lecture, but it does support object orientation. High level is a vague term, but it means easy to understand, closer to human linguistics. But more specifically, it means it's farther from the nitty-gritty of telling a CPU what to do. So for instance, you don't have to allocate memory when you want to create a variable, and you don't have to deallocate memory when you're done using it, where you do have to in lower level languages like C. Also, that high level means that there's all kinds of built-in data structures like lists and dictionaries and sets and tuples and all these things that make your job as a coder much easier, and a lot of the work is offloaded on Python. And then dynamic, that means that we don't have to tell what kind of types we're using when we make variables. So, you know, if you just say x equals a string high, totally fine. I didn't have to tell the program I'm about to give you a string variable, whereas you would in something like C. And then later we can change x to a completely different type, like integer, and that's no problem. Python can handle that just fine. That's what dynamic means in this context. Side note here, if you do want typing, there are advantages sometimes to having strict typing. On the development side, it can help you prevent bugs in various cases. And so since Python 3.6, now there are options for opt-in typing if you want to. But at its core, Python is dynamic like this. So yeah, so it's easy to learn, read, and write. I mean, this is huge for scientists. You know, it's not like we're not capable of learning difficult things, but we generally have other things we're also trying to learn in the meantime. So rapid iteration is just huge here. Batteries included is often used to describe Python. This really refers to the fact that Python comes with a massive, what's called standard library. So there is a huge amount of built-in functionality, modules, and you know, you don't have to write a Fourier transformation function yourself. That kind of stuff is out there. already. So you don't have to reinvent many wheels when you're using Python. All of this makes for a really rapid development cycle. It's often called a glue language. This kind of refers to the fact that while there are some things that Python maybe doesn't do super well, like low-level memory management, it doesn't prevent you from writing small bits of your code in, if you would like to, something like C or something like CUDA or OpenCL to run on the GPU, and then glue all these little bits of functionality together with Python. So I would say, this is to those who would say Python can be slow. First of all, the vast majority of the time it's fast enough. And when it's not fast enough, you use it to glue together, little functions here and there that can be super fast if you need them. But then these last two things really are huge. The community of packages that have already been written in Python, particularly in data science, is just astounding. And then, the fact that it is free and open source is no negligible, attribute. That's really amazing. You can go right in and see exactly how things are done. You can dig into Python and say, how did they do this? And also, it's not owned by a company that if that company goes out of business, the future of the language is in question. So all these things are great. Potential weaknesses are, while it is faster to develop, at times, in certain cases, it can be slower to execute compared to compiled languages. So if you have a function, one function that is executing 1,000,000 times over the course of your program, you might want to look into speeding that one function up. And as a glue language, it's easy to do that with Python. There are ways to write little C extensions to write just this one function in C, and then look into things like Python or Numba to speed up little bits of code. So other minor weaknesses that really for our sorts of purposes are so easy to circumvent that it's just awesome for our needs. So I want like the terms I think here are one of the main bits of confusion that I want to clear up. So this is, while it's a boring slide, it's an important slide. When I say Python interpreter, I am referring to the program that actually runs the code. It's the word Python on the terminal. When you type Python, in a script, that word Python is referring to a program, and that is the Python interpreter. It parses your script, it compiles and interprets it. So that is the Python interpreter. It is the thing you install when you install Python. A module is an organizational unit of Python code. Usually this just refers to a single file that ends in .py that contains some Python language inside of it, some Python definitions and expressions. The strict definition of module is a little more flexible than that, but really most of the time we're just talking about a single file, whereas a package is a collection of modules, a collection of files or sub packages. So most of the time when we say package, we mean a folder on your computer that has Python files in it. And usually this folder, to make it a true package, is going to have this magical init file, underscore, underscore, init. When you see these double underscores, sometimes that's called dunder init file. This file can be empty, and really just its presence, an empty file called init in a folder indicates that this folder is a package that you could import into Python using the import folder name syntax. The word package also frequently refers to the installable Python library or application itself. So when we say NumPy or Matplotlib or Pandas, these are all Python packages that you might install. And what they actually look like inside is folders of Python files. A package manager is something that lets you install, uninstall, update, remove packages. So the two we'll talk about today are pip and conda. These help you install packages. A virtual environment is going to be a collection of packages, settings, and a Python interpreter. And the virtual here, well, really an environment is your collection of Python and the packages you've installed and maybe some settings. Virtual environment really refers to the fact that we can set up little contained environments and switch between them dynamically. And I'll go into why we might want to do that. But right, so you might have NumPy and Matplotlib in this one, and then some other packages in a separate environment. And that's really a key part of doing data science is setting up virtual environments. And then an environment manager is just a program that helps you create and delete these environments. And for today, we'll talk about conda. But if you've seen these programs, virtualenv or venv, these are other variants. Again, there are so many different ways. There's tons of package managers, tons of environment managers. So a little sneak peek here. These are the things that, sorry, sneak peek is next. For the sake of this, I want to talk about the Python interpreter itself, package managers, and environment managers. And there's a lot of overlapping functionality here. So, you may read like conda is an environment manager, and that's true, but it's also a package manager, and that's confusing. And pip is a package manager, but it doesn't, control environments. Whereas venv, all right, there are dozens of programs out there, each of which does some overlapping bit of these three things here. So a Python interpreter manager is something that might let you install Python 3.7 and then Python 3.8 and then 3.9 all on the same computer, so you can switch between them. So if you want to, if something requires Python 3.6, you might need to install Python 3.6, and then somewhere else you need to use a different version of Python. And so an interpreter manager is something that does that. PyEnv is an example of that, but for today we'll talk about conda, which lets you install different versions of Python. An environment manager is something that lets you create these little isolated collections of an interpreter and its associated packages. Venv is a very popular one. Conda also does this, and so outside of data science, you'll see people use these two a lot, PyEnv and venv, to set up a virtual environment with a specific version of Python. Conda lets you do all that, and so I'm really going to focus on that. And then there are package managers. Pip is just one, actually. Conda also lets you install packages. So sneak preview, I like to think of it like this. I'll come back to this slide. But just remember that there are lots of programs, some of which overlap in their functionality a little bit. And eventually you can kind of get down to knowing this one satisfies my needs for this particular purpose. So what does it mean to run code in Python? It means executing a script like this. So let's say you have some file on your desktop, and the contents of that file is print hello world, and you open up a terminal window and run Python, and then the path to that file, it will execute that script, and you've run some Python. The other way that is often done is using an interactive console. This is often called a REPL, or a read, eval, print loop. So it's going to read what you type in there, it's going to evaluate it, and then it's going to print it, and then it's going to go back and let you do it again. So this is interactive usage, and both of these are very common ways to run Python. So just to show you here, if I go to my desktop, I'll be using a terminal a lot in Mac. You can go to your applications and just use the terminal here. On Windows, the command, the CMD command window, the command shell is a similar thing. And we're going to talk about how to install Python and stuff, but assume you've got Python installed. You'll see I have on my desktop this file hi.py, and if I open it, the contents are right, like what I said, and I can just I will explain that in just a second, Allison. If I run Python and then just drag this file hi.py, I've run some Python, and I can, now I'm off and running. Allison, the name of that program is VS Code, and I'll mention it at the end. Okay, so what is this Python interpreter? What is this, what is this magic program I'm running? The Python executable, when I say executable, I mean program, is the thing, like I said before, that does the work of parsing your English language Python code compiling it into bytecode, which is something that this program Python itself can then execute. So sometimes this is called the interpreter. It's sometimes called a virtual machine. It's got all of these characteristics. For our purposes, the Python interpreter is the thing that runs your code. So where does it live? If you on a Mac, if you go into your terminal, let's say before I've installed conda, which I'll get to in a second, we might just be in this situation. I could say which Python, and which is a command that lets me say, where is this program? It'll show you, there it is. And if I say, what version do I have? It is this. And so the point here is that Macs come with Python pre-installed, but they come with an ancient version of Python. And so the take-home message here is that you should not use it. So Python 3 has been out since 2008. Python 2, this built-in version that you get with Mac, is end of life as of January this year. And so for this and many, many other reasons, don't use the version of Python that comes with your Mac. On Windows, I'm not sure if there is one built in, but we're going to install one ourselves. And here's where it gets a little confusing, because there's so many different ways to install Python. Of course, the most obvious way would just be go to Python's official website, python.org, and there is a downloader, and you can use it. You can also somehow get Python from Anaconda, Miniconda. If you know Homebrew on Mac or Chocolatey on Windows, you can get them there. And there's this other thing, PyM. So there's all these different ways. And what gets so confusing is if you use all of them, like your system version, perhaps, your operating system version, or maybe you use Homebrew to install it, or Anaconda, or then you go to python.org and download it. What happens is eventually, the joke here is my Python environment has become so degraded that my laptop has been declared a Superfund site. I actually had to look up what a Superfund site is. It's an area that is so polluted that they've basically abandoned it, and it's a problem. So be cognizant of the way you acquire Python, because you can get into this situation where it's like, here's a Python, and you're like, where is this thing anymore? And you don't even know where it is. And so the too long didn't read here is I'm going to encourage you to just use Miniconda to get that. And and I'll get back to Miniconda, but Conda frequently comes up as what is called an environment manager. And so let's just step back and just talk again about what is a virtual environment. So as I said, a virtual environment is a collection of packages you've installed, some settings, and the Python interpreter itself. And by it being virtual, it really allows you to have multiple of these collections. So you might have, in your home directory on your computer, you might have a folder inside of which is a folder of folders. And each of these little folders is a self-contained environment. In fact, I have this here. So if I just open my home directory here, you'll see I've installed Miniconda. And inside Miniconda, I hope you can see this. I don't think I can make the text bigger here, but inside of this is a folder called envs. These are all my environments. So each one of these has somewhere inside of it a Python, the Python interpreter itself, like there it is. So it's got the Python program, it's got some packages I've installed, and really importantly, they're self-contained. So I can just kind of delete these, recreate them, getting to Anaconda and Miniconda in a second. Right, so that is really, think of a virtual environment as it may be a literal folder on your computer. It may not be. In Miniconda, in Conda, it actually is. So yes, hope that makes sense. If not, feel free to ask questions about what is this virtual environment thing. I'm going to keep going. Do you make a new virtual environment? I will talk about that. I liberally make virtual environments usually for different projects, not necessarily scripts, but let me put a little more context here. Why would we even need this? So imagine this scenario, you install package A. Package A happens to depend on some other packages, and when you use a package manager, as I'll tell you in a second, to install some package, it tends to, I'll get to that in a second, Felix. It tends to install some other packages. So let's say package A wants to install NumPy, but this package requires an older version of some other package, NumPy, less than version 1. Everything's going great, but then you try out some other package, package B. You run pip install package B. Package B also depends on NumPy, but this one uses some new features in NumPy and requires version 1.1 or greater. If in many cases, if you just do pip install, no problem, it'll just install the new version of NumPy over this one, bonking this, and now you have a broken environment. And package A may no longer work. So a solution here would be to create multiple virtual environments, each of which contains the dependencies you need for a particular application. So Alyssa, this is sort of an answer to your question. You might have this project you're working on over here for some genetic sequencing, and it uses this package and this package and this package. Hopefully you can find some combination of packages that works for everything you need in that particular application. And then you have some other one that uses, unfortunately, a really old version of Python and a really old version of something else. That's when you would make a different virtual environment. So you don't need to have them all running together at the same time. In some cases, it may not be possible to simultaneously satisfy the dependencies of every package you'd like to have available to you at the same time. But that's honestly not really your issue. That's the developer's issue. And you should open an issue on that program's page and say, this is incompatible with NumPy version whatever, and I'd really like to use that. And they might tell you something about why it's difficult to do. But this is not your problem. Good uninstallers to get rid of dependencies, older Python versions, and Anaconda. So one of the nice things about using Miniconda or Anaconda, which again, I'll explain the difference, is that by making a virtual environment, I could literally, go into my Miniconda M's here. I could just delete this and it's gone. It's completely gone. It hasn't muddied up my system in any way. I haven't left some trail over here or over here. So that's one of the main things. And actually, I think I'm about to say that. Yeah, so using environments keeps your globally installed, sorry, hang on a second. Lost my chat window. Yeah, it keeps your globally installed packages to a minimum. So it's a really good idea not to install base Python, using python.org and then just willy-nilly start installing packages. It's kind of convenient at first because it's they're available to you everywhere, but it leads to this issue where you're like, well, it worked fine on my computer. And when you try to tell somebody, how to install something, you were using something perhaps that you didn't necessarily know was available to your Python because it was just this mess of stuff. And so virtual environments let you make that really nicely contained. And so when it comes time to uninstall it, you just conda remove and it's gone. As for removing Anaconda itself, you can just delete that home folder and it too is gone. So yeah, try not only should you not install things globally into your computer, we should use little virtual environments, but within Conda, which I'll talk about, try to avoid installing things in your base environment. So after you install Conda, you'll have this fresh base environment. I would encourage you not even to use that too much. Make a separate virtual environment for most of your applications. You can even have a separate virtual environment that is like your kitchen sink. If you like to have all these things together, that's fine. Make an environment that is like your all environment or your Python 3.8 environment and do, dump everything you want. Yes, I'll show you the base environment. Actually, so Andrew Ward asks, where is this base environment? The base environment actually is pretty much muddied up in the folder itself. I think, let me talk about installing Conda and then I'll get back to that question. Right, so Conda, which I've referred to many times now without really defining. Conda is a program. It is an open source program. It's a cross-platform, language agnostic. It's actually not even Python specific. Package management system and environment management system. Oh, you know what? I forgot to mention And I'm going to just go back to the beginning now. On this first slide, this link down here, nic.med.harvard.edu/Python, this is where you can download this PDF. So I have a lot of like links and stuff here. Don't feel like you have to write them all down. You can get this whole PDF there. So going back to what is conda. Right, conda is the program we're going to use to create these environments, and we can even use it to install packages. Yeah, this is from their website, that they're just describing that. So how do we get conda in the first place? There are two different ways, anaconda and miniconda, which I'll talk about, I believe, on the next slide. But what I would encourage you to do is download the latest miniconda installer. So we just go to miniconda, grab the version for your platform. Thank you, Federico. And then, right, and then follow the installation instructions. It might be double clicking on a package, or it might be running a shell command, but it's pretty clear how to install it. A side note here, if it asks you whether you would like to run conda init, unless you know that you don't want to, should probably just say yes. What that will do is make it such that when you open a new terminal window, for instance, on Mac, if I open a new terminal window, let me close that one. I'm already, you can see I have a little thing here telling me which environment here. It's already activated conda for me. So I'm already in my conda base environment, and everything is ready to go for me to use conda, this program conda. So conda is a program I just type at the command line, and I'm ready to go because I've used conda init. And now I'm off and running, able to make environments. And the main, there's a cheat sheet later, but the main command to create an environment is something like conda create -n. That's the name of the environment. You can name it whatever you want. And then you might use a version of Python, but like I said, this is Python agnostic, so you actually don't even need to install Python at all. So for instance, I could just say conda create an new env. Let's just see what happens. Sorry, I'm making the text bigger. It's going to do some stuff, and then here it's telling me it's about to drop this new environment right here. So I've installed miniconda, I've installed it into my home directory. So this is the whole miniconda thing. Inside the envs folder, it's going to make a new folder for me called new env. If I just say, yep, do that, let's go ahead and look at this folder now. So I'm in my miniconda envs, new env, and right now there's almost nothing in there. There's no Python, there's nothing at all because I haven't even installed a Python interpreter. I've just got myself a little folder where I can dump stuff, and that's great. To actually use that environment, to indicate to conda that I want to like be in that environment, I have to use this here, conda activate, and then the name of the environment. So right now I'm in, and Python related things or things I do, like conda install, packages I install will all get installed into this specific environment. For instance, I can say conda install Python itself, and I'll give it a version. So now I'm actually installing the Python interpreter, and it's going to tell me I need some other things. Sure, go ahead and do it. So I could make a separate environment to install a different version of Python. For instance, Python 3.9 just came out, and if I wanted to play with that, I'd probably make myself a new environment and see, does that affect anything? So now that I've installed Python, let's see what it did to miniconda here. And so you can see that this folder new env now has a handful of things in it, including some executable files, some libraries, and a whole lot of stuff associated with Python itself. But if I just deleted that folder, it would be gone, and I haven't muddied up anything. So about this base environment, where is the base environment? If I go conda activate base, and I go back to my base environment, if you, for instance, now if you say which Python to say, if I were to just run Python now, like if I run like Python version, You can see I'm no longer on that 2.7 version that my operating system uses because my conda environment is active. I'm in this base conda environment and it uses Python. And if I said which Python, what is that? Well, you can see that it's really at this top level of miniconda. So unlike all of the other, you can use the, question over here is on PC, does one need to use the command window or can one use a shell client? Shell client's fine. Like literally any way you can get yourself to a terminal window, you can use PowerShell. There are different ways of activating conda. So, you'll have to know what you've activated, but there are so many different ways any terminal will generally do. But finishing my answer to the base environment, this whole thing is kind of the base environment. So this, this bin here are the programs that come with conda, like there is conda itself, for instance. This is the Python that comes built into miniconda to run it. So really this whole thing is kind of your base environment. So I've been talking about miniconda, anaconda a lot. Let me clarify this, because this is a common source of confusion. So conda is the program. Conda is the program I run to manage environments and maybe install some packages. It runs on Windows, Mac, Linux, and technically you can use it without either anaconda or miniconda. It is a program. Miniconda and anaconda are distributions. They contain conda and some degree of other things. So miniconda, is a minimal installer for conda. So miniconda is a distribution that installs the conda program and Python and some bare number of additional packages that is required to run those things and other package installers like pip. So miniconda is the bare minimum. Anaconda, which gets a lot of discussion, gets mentioned a lot in scientific computing, is a massive distribution that contains conda, the program conda, it contains Python, and it contains an additional like 250 scientific computing packages that are pre-installed into your base environment. It also comes with a GUI, like Anaconda Navigator, that helps you, manage environments without typing conda create on the terminal. So that is the difference between miniconda and anaconda. The reason I tend to say use miniconda is because, well, first of all, this is a 3 or 4 gigabyte distribution. Actually, let me say, you might want to use anaconda if you know that you need to use like a large number of these packages together, like pandas and numpy and matplotlib. And those are easy to use together, but there might be some difficult things to simultaneously get working. That is what is really impressive about Anaconda. They have made this massive collection of things working simultaneously in your base environment. But if you are actively, but then if you sort of muddy up your base environment, you might want to just kind of completely uninstall and reinstall Anaconda. So I tend to prefer miniconda, which gives me nothing at first, and then actively install just what I need in a new environment. And you could even try to, recreate maybe, let's say, 50 of these packages or 100 in miniconda too. Like you could install miniconda and then try to get the distribution that comes with Anaconda installed as well. So miniconda is a minimal install. Anaconda is a massive full install. Both will work. Both come with conda. Does that? I hope that gets to. Allison, I hope that gets to your question, and if not, feel free to ask another one. So within conda, there is the concept. Let's see. Have I talked about installing? This is a little out of order. I'll talk about this. I'll talk about this slide, and then I'll go back to that one. So this is just a little cheat sheet of sort of what I feel as the if you go in your terminal and you say conda help, you'll see that there's a lot of stuff that conda can do. That can be a little confusing. This is the bare minimum of stuff you should know. You should know how to create a new environment and how to activate. Oh, sorry, this is an error. Activate. You should know how to activate that environment. If you want to get a list of all your currently installed, created environments, you can use conda info e. You can search, the bottom half of this is conda as a package manager, which I'll talk about next. So this is controlling environments. The bottom half is actually installing packages like NumPy or matplotlib. You can search for a package name, you can install, remove, or list all the packages in your current environment. So just as an example, if I did conda info e, I can see, there's all my environments, there's the name of them, and there is where they live. And if I wanted to activate one, conda activate, boom, and now whatever collection of packages I have in that environment are available to me. I could even say, conda install some package, and it'll go out and grab that for me. And I could say yes, and now I've got a new package called requests installed in that environment. I want to talk about channels briefly. Channels are locations where packages are stored. It's kind of like an index. So there is a default channel. When you say conda install some package, it will go to the default channel. Actually, I'm realizing it could be confusing. These packages are, they live on something called Anaconda Cloud. So this is a server that hosts packages that when you do conda install, it is going to search Anaconda Cloud. And within Anaconda Cloud, there are a variety of channels. These let you they're like indexes for packages. So for instance, I could create my own little channel that I could upload some programs to, and I could have somebody install them, but they would have to specify my channel because, in other words, my channel isn't available to literally anyone who installs conda. So you can specify these non-default channels. That's a way you can share your stuff through conda. You can make your own channel. But I also want to mention Conda Forge, which is a really awesome community-led channel of packages for conda. You should absolutely, for scientific computing, add this to your config using this right here. This has a tremendous amount of scientific packages that you might want to use. And you can also contribute your packages to Conda Forge. They make it super easy if you've got something that you'd like to share with the world. So that's what channels are. So conda itself is self-contained. This is sort of one of the reasons, Felix, why we don't need a great uninstaller for this, because we can kind of just create a little folder in our home directory and dump it if we want to. This also makes it good for remote jailed environments like O2, where you don't have special privileges, you don't have super user privileges. So you can dump a conda folder in your home directory on O2 and then create environments there. There is a guide here on Research Computing's website on how to do it. There's a little bit of, there are different ways to do it, and they encourage you to use the conda module, load conda, which you absolutely can do. You can also just install conda in your home directory because it doesn't need any special purchase. So I've been bleeding into package installation already, but let's just say, all right, we've got some environment. Let's start installing some packages. Packages are awesome. Packages are what make the Python world go round. There is an amazing amount of packages out there. There's, on PyPI, which is the kind of standard place where packages live. I'll get back to PyPI. PyPI, well, teaser. PyPI is, if you've heard of pip, which I'm about to talk about, pip installs packages from PyPI, conda installs packages from Anaconda Cloud. So these are both servers that serve packages. PyPI is really the Python standard. Conda came later. There's just tons and tons of packages out there, hundreds of thousands. These are some good links, by the way. Like Awesome Python is a curated list of really great Python frameworks, libraries, softwares, and resources. You'll see that this Git repo has 89,000 stars, which more than anything means that there's a lot of eyes on this repository. So if there are awesome new things, chances are somebody's going to suggest that it get added here. And if there's something that the community as a whole just kind of doesn't like, chances are it's going to get removed from here. They're broken up into different applications like science, and you could see, a handful of sciencey things. So awesome, awesome Python is a good thing. SciPy also has a list of good packages you might want to be aware of. And how do we install them? Well, we can do one of these two things: conda install NumPy or pip install NumPy. This is if I wanted to install NumPy, the package. So it's perhaps getting a little confusing here now because we've added yet another. So we've got conda, we've got pip. What's the deal? This is often confusing. So I want to go back to this thing that I showed you. So we've talked about conda here a little bit. I've talked about how conda acts as a manager for Python interpreters. It lets you install Python itself, different versions. It lets you manage environments. And it also lets you install packages, conda install requests, like I did a second ago. So pip also lets you install packages, but pip is a dedicated package manager. It will install packages into whatever the current environment is. So pip works fine with conda environments. If you've conda activated your a specific environment and then you do pip install some program, it will go into your conda environment. So they do play well together, but they both also act as package managers. I hope that made sense. So really, if we talk about the difference between these two as package managers alone, forgetting for the moment that conda is also an environment manager, if we just think of the role as a package manager, what are the differences? It's a little bit subtle. There are some differences. In many cases, you can use either, and it's not terribly problematic to use either, but there are some things you should know. Pip installs Python packages only within any currently active Python environment. Conda can install literally any package. It doesn't have to be a Python package. You can install Julia packages, R packages, C packages. Conda is a general binary package installer. That's why conda can install Python itself. It literally installs any program as long as it's available on one of the conda channels. But it only installs it within conda environments. So if you use some other environment manager, like I mentioned a second ago that there are environment managers that are not conda, like Vend, conda is not going to install into that. It needs to install into a conda environment. Another important difference between the two is that when you do pip install, it doesn't ensure that the dependencies of every package is fulfilled simultaneously. So each package is going to have a list of things it depends on. Package A depends on NumPy and Matplotlib and SciPy, and package B depends on requests and Django and whatever. And each of them are going to say some specific version of their dependencies. Pip doesn't actively make sure that every package you have installed is all of its dependencies are simultaneously fulfilled. So if you pip install something and then pip install something else, it is conceivable that that second thing you installed will overwrite one of the dependencies that first thing needed. And like I said, you might have a broken environment now. Conda, on the other hand, does attempt to satisfy all these dependencies at the same time. So it is sometimes billed as being something that lets you make more reproducible environments. So if you get something working with conda, and then you say, you can share that environment, chances are it makes more predictably working environments. However, you more often will run into unsatisfiable dependencies, which is to say you try to conda install this, and this, and it says, oh, sorry, can't do that because they don't agree with each other. There's something incompatible here. This needs version 1.1 of this, and this has said definitely not any more than version 1. And it just can't do it, and it'll fail. Sometimes that failure is because it really would have caused a problem. Other times that failure is just because the developer didn't update the list of dependencies. And they could just go in there and say, you know what, version 1.1 is fine, but their conda recipe says it needed, so the developer didn't yet update it. So in that case, like pip would let you just kind of play with it, and maybe you're fine. Maybe it doesn't, so pip is a little bit more Wild West, just throw things in there, and you may have issues, you may not. Conda is going to upfront give you an error. For science, it's worth being aware that conda versions of like NumPy and heavy scientific computing will come with the compiled Intel math kernel library, MKL, which can make a lot of your CPU-based stuff faster. So using NumPy installed from conda in a conda environment actually can be faster than using pip installed NumPy. For details on that, it's a little more complicated, but for details on that, you can check this out. But if you are a heavy user of, say, linear algebra stuff, it is definitely being aware that installing NumPy from conda might speed things up a bit for you. Personally, I use conda to make my environments, and then I just default to pip install when I want to install a package, unless there is something like really tricky to install, and then I use conda. Oh, there's actually an important, yeah, I meant to put this slide. There's an important detail here, which is conda installs pre-compiled programs. So this is slightly complicated, but a developer might write a Python package that, remember I said earlier, we can use C or other compiled languages sometimes within a Python program to speed up a small bit of code. So a program might write a little bit of code in C and then want to distribute it with their program to accelerate just that one bit. But the problem now for that developer is if they ship their source code, as is standard for Python, they ship their just the English language code. It is now up to the receiver of their package to compile the little bits of C that they have put in their program. So you, the user, might need to now have a C compiler installed on your computer to actually make that work. And occasionally, if you use pip and you run pip install something, it will fail to install, and it'll usually say something like failed to build wheel. Wheel is a fancy word for a built package. So what that means is like pip, the installer, was trying to compile some non-Python code, maybe C code or something, and it failed because you didn't have the appropriate compiler on your computer. Now you could go out and get that compiler and be fine with pip, but you might run into issues like that. Pip now does have a way to distribute precompiled stuff, so the developer could opt in to having compiled all this for Mac, Linux, PC ahead of time, but they don't all do that. Conda is much easier to do these sort of pre-compiled programs and distribute them. So this is why I say back a couple slides, if there's a tricky to install package, or if somehow pip install package fails, give a try to conda. It might just work. And it might just work because because it depended on some non-Python compiled stuff that they have bundled for you in their conda package that they didn't in the pip package. That's really the message I want you to take from that. I'll get back to that comparison in a second. These are the essential pip commands: pip install, pip uninstall, pip list, pip search. This is the same sort of thing. So actually, let me just mention here in my conda environment, if I say, let's say pip install something, it's already in there. Pip install TIFF file? No, how about TIFF? Oh, it's already in there. Well, what I wanted to show you is if I say conda list, this was going to show me all of the packages in my environment, conda list. What you'll actually see here is it tells me some were installed with conda and some were installed with pip. So if you're ever like, did I install this with pip or did I install this with conda? You can, in a conda environment, if you say conda list, it'll tell you just that. And more specifically within conda, not only will it tell you, yeah, this came from conda, but I got this from the Conda Forge channel, etc. Whereas pip list will tell you what's available to you, but it won't tell you where you got it. Right. So also, just to mention, pip can install from lots of places. By default, it goes to PyPI. So PyPI PyPI is the Python package index. So whereas Anaconda goes to Anaconda Cloud, PyPI is at pypi.org. This is where pip goes, but, and this is a super useful tip, it can install from Git repositories. So if somebody's like, hey, there's this cool package on GitHub, you can actually use pip to install directly from that Git repository using this sort of syntax. So you could go pip install git plus, and then the URL to that package on GitHub, and it'll install just fine, even if that developer hasn't put this program on the Python package index PyPI. You can also, if somebody's like, oh, I'm working on a branch that has this feature, it's not in the main branch yet, and you're like, I would like to see that, you can use pip install and then use this syntax at the end here, and then the name of the branch, and you can install that branch. So that's a really great tip. This is another reason why environments come in handy, because it lets you just kind of install these bleeding edge things to try them and know you can just delete the environment later if you want to. So good tips to have there. You can also install local things that you might be working on. So, right, so just as a summary of the difference between these, pip installs things from source. Sometimes that requires you to have a local compiler. Conda, you can generally get around that requirement. Conda installs any package type, doesn't have to be Python, whereas pip is a Python package installer. Conda also creates environments. Pip does not. It requires that you have an environment like either created with Conda or some other environment manager. Conda has strict dependency checks, whereas pip does not. And then they source things from different places. Often you can use either one, unless a developer has only made this stuff available on PyPI, in which case you probably can't use Conda install. Hope that makes sense. To recreate environments quickly, you can use two useful tools. In Conda, you can use what's called an environment YAML file. This is a file format, and this is what it looks like. So to get more detail on this, here's a URL. But what it lets you do is create a new environment. So rather than saying conda create name something and then proceed to pip install or conda install all the packages you want, you can make an environment file like this and then just say conda m create -f and then the path to this file. And it'll go ahead and make it for you. You can even, if you see the syntax here, you can even specify some things to be installed using pip. So everything up here would be installed using conda, and then everything down here would be installed using pip. So let's see if I can give you an example of that. Clear. So let me go to my desktop, and let me activate my base, conda activate base. And on my desktop, let's see, I have a folder Python envs. So let me go Python envs. And in that folder, if I list what's in there, here is a environment YAML file. Let's see what is in that. This is what it looks like. It's the same as this over here. And so if I go, actually, let me check. I might have already run this. So I'm going to run conda info e to see the names of my current environments. And do I have one? I do not. Great. I was looking to see if I already had one called my env, because that's what this one is going to be called. So if I go conda env create f environment.yaml, it will check to make sure that everything works. This is this moment right here is where it's doing all that dependency checking to make sure everything checks out. And in a second, it'll ask me if I actually want to do it. And so that's a nice way to get things installed quickly. Can be a little slow here. So on pip, you can use a format called a requirements text. This is just a text file where each line is a separate pip installer. So just as you could say pip install numpy, or you could say pip install numpy greater than whatever, if you have a file that has on each separate line something you want, then you can just install it like this. So, oh, actually, it looks like my previous thing made an environment, and I'm going to go ahead and activate that environment. If I say conda list, you'll see it's got some of these things I asked for, like numpy and scipy. But I have this requirements file here too that has some additional dependencies, and it's in the same directory. So I might say in my conda environment, I could go ahead and use pip now and say pip install our requirements.txt, and it'll go ahead and install everything that's listed in that. So, you know, I'm encouraging you to sort of be make environments quickly, not quickly, but make environments liberally and delete them liberally. I'll get to that, Andrew, in a second. And one way to facilitate making them and deleting them is to have these types of files. So one question is, could you go over the creation of this YAML file, or is this just a text file you made, or is it through conda or by copying a previous environment? So yes, you can do any of those things. You can export your current environment. I forget the syntax for this. But what I just did there was just made a text file, gave it the .yml extension, and then there's a specific syntax you have to follow. This is the YAML format, and it looks like this. And to learn more about that, go to the this page here, where it'll walk you through. Let's see, YAML. Here's how to create an environment file manually. So it's just a syntax you have to follow. And you can also, in here, it'll tell you how to export. So conda env export will export your current environment. Hope that helps. Go to this link for more info on that. Okay, so I'm actually going slower than I anticipated. We might not have as much time at the end for questions, so absolutely just dump questions in the chat. I am keeping my eye there. But this is a big question that I get a lot. It's like, where did that just go? When I just said pip install something or conda install something, where did it go? And when I type in Python import NumPy, how does Python find that? Where is that coming from? This for me was you might not use what I'm about to show you a whole lot, but I found it like satisfying and somehow demystifying to know where all this stuff is. So the answer is Python finds stuff with this variable. So sys is a Python module. So if I go import sys and print syspath, syspath is a list that Python maintains that tells you where Python is going to look for packages and modules. So when you say import something, that something, NumPy, a module or a package. And remember, a module is just a file with a Python extension, and a package is just a folder of Python files with a init.py file. That has to exist in one of these places that is shown to you by syspath. So it's going to look a little different on Mac, on Linux than it is on Windows. So this is what Mac and Linux looks like. This is what an example that Windows might look like. So if I run this here, I'm going to let's see. I'm in some environment. If I just open my Python interpreter, side note here, I very rarely just directly use Python like this. I use IPython, which I'll talk about. But now if I say import sys, sys is a built-in Python library. And if I say syspath, that there is a list of locations on my computer where it might look for things. So let me just open this folder here. So you can see there is a whole bunch of things. Some of these are like the built-in library. So for instance, OS. There, some of you use Python. You've probably used the import OS. OS is a Python module, and it literally lives right there. So again, we are now in my miniconda environments, my environment. There's a lib folder, and inside that is the Python. And because this is a built-in standard library thing, it is in that. So this syspath is an awesome way, if you're wondering where things actually live, they live right there. Another thing that I'll point out is this site packages. So site packages, let me open that. Site packages is where all of your installed packages tend to go. So when you say pip install NumPy, it is probably going to go into your site packages folder. So let me open this one. So right now we are in Miniconda M's, my environment, lib, Python, site packages. So in the Python folder, there is this site packages folder, and this is where all that goodness goes. So somewhere in here, there's NumPy. And if I wanted to look at the source code, you know, I could go ahead and open NumPy in my text editor and straight up look at how they have done stuff, which is an awesome feature of Python. I could even, just so you know, I could even go in and edit this. In fact, let me just to prove this point, if I in the init file of Python, if I say print hi Talley, and I save it, and now I import NumPy, I have messed up and altered my NumPy. So Python being open source like this and shipping source code itself is super open to you. And I very much encourage you to go into these things, see how they do them, because it's an excellent way to learn. Another nice thing about having an environment here is, you know, if I really screwed this up and I somehow didn't like unsave what I did, I could just make a new environment. There are better ways probably to muck about with NumPy, but you can do something like that. That is where a lot of your packages are going to live. So the site packages folder is a really good thing to just be aware of. In practice, you're probably not going to go in there too much, but that's where your packages live, and this is exactly how you find them. Yeah, so that answers the question of where did it install site packages. Windows, it's going to be a little bit different. Windows doesn't bury it in the Python itself folder, but just different. And this is another tip. You can modify sys path yourself. So if you make a local Python file that you would like to be able to import, by default, actually, you'll notice in syspath, this very first thing here is the empty string. So that means the current directory. So that means Python will look in whatever my current directory is, which again is wherever I was when I started Python. So I'm on, you know, my current directory right now is this folder on my desktop, Python ems. And let's see what that's got. That's got a file called my module. So if I just did import my module, it works. It's fine because one of the items on syspath is the current directory. That is just a default thing in Python. But I could absolutely, this is just a Python list here. I could syspath append, you know, some other like downloads. Let's say users tally downloads. And now, you know, if I have a Python package in my downloads folder, I'd be able to import it. So go ahead and modify syspath. The next time you start Python, it'll be gone. It's not a permanent setting or anything like that, but syspath is where Python looks for stuff. Quick tip, you can also, if you import a module like this and use the dunder file method, it'll tell you exactly where that thing lives. All right. So earlier I mentioned how to run a code in Python. Again, we can just run Python and then the name of some script or use an interactive console. Like I just showed you, we can type the word Python and then just say start typing some Python. But don't do this. There's almost never any need for this. Use IPython or Jupyter. So IPython is freaking awesome. It is the de facto standard for using Python in an interactive way, where you type something, it evaluates it, it might print out the answer, and you can keep going. Basically, it's a souped up interactive console. Just use it instead of Python. You might say, how do I get IPython? Well, let me see do I have IPython here? I don't. IPython is not found. So I can just say pip install IPython. I could say pip install IPython, and it'll install, and in a second, I should be able to run the command IPython. And that brings me into a much better version of the terminal, which has a handful of super useful things like tab autocompletion. So if you want to say what is available on some object, you can start typing something and then just say hit the tab key. So for instance, if I say import some module like OS, and then I say OS period, I want to access some attribute of this module, but I don't really know what's there, or it's some new thing I'm exploring. If I hit now the tab key, you'll see these are all of the things that are in there. And if I start typing PA tab, well, those are all the things that start with PA. Okay, so great, there's PATH. That's a submodule. Now I know at least it exists. And if you know something exists, hitting tab is a really rapid way to whip through code. But also there's this awesome thing called object introspection, which is basically the equivalent of MATLAB's like help something. It's like built-in documentation. So if the developer has written some documentation in their code, you can access that using the question mark. So going back to here, if I say OS path question mark, well, I see that this is some, first of all, I see that it is itself a module. It is not a function or anything. And it has common operations on path names. So let's say OS path period tabs. I don't know what's in there. Oh, okay, there's something OS path base name question mark. What is that? That is a function that returns the final component of a path name. Great. So, if I do some path name, I can see that it's given me the final component of that path name. So this question mark here is super useful in IPython to learn the things you're working with as you work with them. It also has a handful of these things called magics. You should go to this link here to read about them, but they allow you to do things like this, like run some script. So this would be the same as going back to the terminal window, running Python, execute some script. However, I don't need to exit IPython to do that. I can just run the script in line there. And really importantly, whatever variables or things that were declared in that script, let's say I've declared some functions or some useful things, they will continue to be in my what's called namespace in IPython, such that I can access them after the fact. So if you're like piloting out something and you've got some script that you want to be able to run repeatedly, but also tinker with after you've run it, then this is a handy trick. Also, your command history is there, so if you press the up and down key, you can go back and forth. Jupyter Lab, many of you probably heard of Jupyter and Jupyter Notebooks. Jupyter Lab is just an incredible multifactorial thing. It is not one thing. Well, Jupyter is a whole environment of ways to work with what are called notebook files. No, it's even more complicated. Jupyter is basically an environment of things that let you run a Python server somewhere, access that server through some protocol, through your browser, somewhere else. There's a whole host of tools that go with Jupyter, the most famous of which is Jupyter Notebooks and Jupyter Lab. Go here to check this out. I think many of you have seen this before. I'll show you a quick example. If I exit out of this, and I'm going to go into my all environment, conda activate all, because I just have this one environment where I dump a lot of things. And in there, I know I have installed Jupyter Lab, which is this super cool environment where I can open up a notebook, and I can just start executing code like this, and print X, right? So now I'm doing Python code. It also, one of the main benefits of Jupyter Notebooks and Jupyter Lab is that it lets you also do sort of rich markdown and media. I could embed an HTML video if I wanted to, or I can start using markdown, which is a syntax that lets me do things like emphasize something. And then when I execute that cell, it's in Markdown. And so this is a great way to share content where you can say, I particularly like this for sharing things. So you can have documentation inline like this that is formatted. You can use LaTeX if you know that for math equations and stuff. Lillian, I'll look at that in a second. And execute code inline. You can do things like show images. So for instance, here's the thing. Actually, one thing I'll note here, I haven't even executed this. Jupyter Notebook saves media from the previous execution. So you can see that in the course of running this previously, it showed an image. It's actually saved that image for me. So if I share this, at first, the person will see this, but then they could go in and play with this. And let's say they wanted the image to be smaller. They could do that, and it will re-show the image right in line there. And so I think the word notebook really sums up what this is good for. It is excellent as a lab notebook where you're tinkering with things. You want to show the results in line. Jupyter Lab versus Notebook. Jupyter Lab is just sort of the evolution of Notebook. It now comes with this lots of extra stuff. Like I can have a Jupyter Notebook. I can get an actual console window. I can run widgets and basically use Jupyter Lab now. If you can get it installed, it's pretty awesome. Lillian, when you install new packages, do you install it first in the project environment and then also install it into all? Okay, so all for me here, all is what I named my environment. So if you're asking, yeah, all is not a magic word. When I conda activate all, that's because I personally have made an environment called all. This is not something you can do unless you have done this. And I would have needed to, yeah, so all is the name of the environment. And so if I want something in my all environment, I have to first activate that environment and then pip or conda install something into that environment. So there's nothing magic about that word. I just used it because it's my little way to remember. This is my kitchen sink one. This is the thing that I freely install things into, not afraid if I'm going to break something because I'll just delete it and make a new all. Yeah. Anyway, so that is Jupyter Lab. There is so much to go into. Jupyter Lab doesn't have to be Python even. You can use Julia or R or even C, which is crazy. Jupyter is amazing, and I don't have anywhere near the time to get into that. I will say one thing though. Jupyter is great on O2. There's a page on research computing for some info on that. I found this the other day. I've never used it, but somebody from the Marks lab made something that helps you get up and running where you're hosting a Jupyter server on O2, but you would be able to use it from your local computer. So that's kind of handy through your browser. Somebody says, I've used it, it's great. Great. So there's one accolade for Jupyter O2. Maybe check that out. I do want to say one thing though, it's freaking amazing, but I very often see people feel like they can't think that they can't even run Python without like a notebook or a Jupyter Lab instance running. So I would encourage you to learn Jupyter Notebook. It's an amazing way to share and communicate things, and you might find that you want it to be your lab notebook. But being comfortable on the terminal, also running IPython is really useful for rapid debugging and development. And if you want to remote into some other computer, it's much easier to just get an IPython terminal running than a whole Jupyter Notebook, which requires a server and all these protocols running. So in no way to emphasize the amazingness that is Jupyter, but the vast majority of the time when I am coding locally, I just go into IPython and I don't spin up a whole notebook for that. So don't miss the fact that you don't need to use Jupyter for all that. So lastly, I just want to point out a couple tools you could use. I have maybe less so recently, but I have heard people say, I'd love to use Python, but I really prefer MATLAB because I have this GUI where I can see all the variables and get help. And no doubt MATLAB has an amazing, what's called integrated development environment, where all that stuff is there. You know, they have a lot of dollars to put into the documentation, and that is one of the main nice things about MATLAB. But things are coming along quite a ways in Python. And so, you know, first of all, I'll just point to two what are called IDEs, integrated development environments. PyCharm is one that a lot of people use. I personally like VS Code, which is what you've been seeing me use, in the beginning. This is VS Code. One really nice thing about using something like a integrated development environment is that it can be, you know, it can be aware of your packages that you have available. So if I type, you know, import, let me save a new test.py file. I have to tell it that it is a Python file, but then once it knows it's a Python file, you can see it gives me this like auto completion. I can do tab auto completion, stuff like that. There are going to be little handy things like in this other one, you saw some squigglies here. That's what's called a linter, which is telling me, you know, you might have a problem here. And this is what integrated development environments give you. They have some awareness of your environment and help you with stuff like that. I really like VS Code. It's got a Python extension that is pretty great. Questions here. Am I using IPython like an editor to create scripts and functions, or is there a separate editor? Hopefully I just answered that. I use VS Code as my editor and IPython to execute scripts, or maybe play around with a function that I want to debug interactively. I'll also point out Spider, which is another very MATLAB-like integrated development environment. It's also quite amazing. You can have all these variables shown in there. And actually, VS Code, I forgot to mention, has its own, you know, variable explorer. So a lot of the things that we've come to expect in the MATLAB development environment are available now for Python. So let me just summarize here. And I guess I haven't left any time for questions. Hopefully you've been asking them as we go. Right, so my recommendation, if you don't already know it's better that something you'd like to do differently, would be to start by getting Python via miniconda. I like miniconda because it's minimal. You sort of know what you're installing. There's very little magic to begin with. Create new environments often. Create them, you know, when you want to test something. Treat an environment. Use pip and conda to install those packages. You know, I tend to default to pip, and I use conda if I'm running into difficulties. And I consider environments disposable. Basically, I make them and I destroy them all the time. I use requirements.txt files to create them quickly, or environment.yaml files if I want to create a conda environment quickly. But you know, if something is broken, my first suspicion goes to maybe I've done something in my environment and I create a new one and I test it. As a Python developer, I can tell you, like, you know, 30% of the time when somebody comes to a forum and says this is not working, the answer is, have you tried this in a fresh environment? And then they make a new environment, and then they and then it works. So, you know, as a favorite developers, try a new environment. Question is, what happens to your code when you dispose of an environment? And the answer is, you rarely are saving your code in the environment. So just to give you an exact example there, so this is my environment. It lives in miniconda environments, you know, and here's all my environments, so like my end. But the code I'm actively working on, like the Python code I'm editing and changing, I don't save there. The environment contains my Python interpreter and some packages, but it doesn't contain my work until maybe I've intentionally installed some of my work permanently there, just as a static snapshot of some of my work. But my work lives somewhere else, like in, you know, my Python folder or something like that. So when you destroy your environment, unless you've intentionally put stuff in there, you shouldn't be deleting your code. You shouldn't put your code that you're editing. I mean, you would have to try hard to get your stuff in there. What is a configuration and how does it interact with environments? I'm going to just put the rest of the opinionated summary here and go to questions. What is a configuration? Did I say configuration? What do you mean by configuration? I said configuration, didn't I? I forget. Did I say it with environment.yml? Alyssa, you can either unmute yourself or just add to that. I'm not sure when I said configuration in what context.
Can you hear me?
Yeah.
So you said something about config when you're installing something into config, but also when I'm trying to run scripts in, these integrated platforms like PyCharm or something, it makes me run scripts using a configuration and I choose an environment.
Ah, right. Yes. Thank you, Federico. Good tip. That is a good example. So let me just say, let me close this and open a new. This is not PyCharm, but PyCharm has a very, very similar concept. So let's say I open some folder and I open a Python file, and it's like, looks like you're editing some Python there. You can see down. Let's see. What it means to activate a environment, like in PyCharm, it says, what environment do you want? Let's see if I say, sorry, I'm going to do one thing I want to show you is not showing up. So let me do one thing here. In VS Code, the environment I am working on is shown down here. So you can see this is actually giving me an option to choose between any of the miniconda environments I just created. So you can see all of these folders in M's environment. So the point is that as you on your command line here go conda create whatever some new folder, integrated environments like PyCharm and like VS Code know how to take advantage of that, and you can generally switch between them. In VS Code, I switch between them down here. In PyCharm, you do it in your preferences. I hope this is answering the question. And the reason that it is useful to tell it which environment to use is because all of the features that have this like awareness that tell me like, is this package available to me, or would this give me an error when I try to import it? Those features need to know what environment you're working on for them to be able to work. So I hope that answered the question. One config in these integrated environments is what environment are you using, and that literally is a pointer to that folder, to the Python executable in that folder, specifically the Python interpreter. I'm gonna put this. That was it. I'm gonna put this summary up here. These are some good, yeah. And feel free to email me. I like answering Python questions, and yeah. So feel free. I don't have my chat. Well, okay, chat. Let's see. Yes, you're welcome, Alyssa. I'll stick around for questions. We are over time, so feel free to go. And maybe we can stop the recording, but I will stick around for either verbal or chat questions for a little bit. You're welcome. Thank you. Thank you all.
May I ask a question, Talley?
Yeah, absolutely.
First of all, thank you for this. This was very useful. So I I've been I'm trying to get up to speed with some projects that are using AI for image recognition, and because of my previous experience with MATLAB, I was suggested to work in the PyCharm environment. My question would be, when I install let's say new environment and packages, I'm supposed to install everything via terminal and then access them via PyCharm, or there's a way to do that via PyCharm?
That you don't have to do everything via terminal. Oh darn it! I wanted to open PyCharm and show you. No, all of these. Let's see if VS Code even offers me this. If I say like, yeah, so VS Code doesn't allow me the ability to create a new environment in VS Code. It is asking me to enter the path to an existing one, which I made in the terminal.
Right.
PyCharm, I can't remember. I think PyCharm has a create environment. I think PyCharm does have some awareness. Like you have to somehow tell it what environment manager you're using, like conda. So I'm not the best person. I can actually look this up and get back to you. But what I do know is true is if you do it in the terminal, PyCharm will be able to find it. What I can't remember is whether PyCharm gives you a direct way to create an environment. I do know that once you have created environments in PyCharm, you can install packages via PyCharm. Like you don't even have to leave the PyCharm environment.
And do you think PyCharm is a good idea? Do you think PyCharm is a good idea?
PyCharm is an excellent thing. I mean, tons of people use PyCharm. There are subtle differences with the way it introspects your code. So, all of these things are evaluating your code to tell you things like, this might be an error, this might, PyCharm does it in what's called static analysis. So it doesn't execute any of your code, which has its advantages in speed, but sometimes it can lead to tricky things because Python being a dynamic language, you can declare things and define things in a dynamic way such that like some variable is actually defined dynamically somewhere else in the code. VS Code would know that variable existed, whereas PyCharm might not. That's a rare sort of case, and so I would say just start with either of them. They're both totally awesome. VS Code is a little bit more of a minimal interface, so it doesn't sort of hit you over the head with all kinds of things. PyCharm could be made to be minimal. If you hide a lot of things just because you don't want to think about them, you could absolutely do that with PyCharm. I think in terms of feature completion, they're not too dissimilar. Like most of the things you can do in one, you can do in the other. Maybe the variable explorer, maybe the strict MATLAB-like interface, the scientific interface might be a little bit ahead in PyCharm. So that's probably why that was recommended to you, and maybe not a bad idea. But maybe play with VS Code too. I leave it up to you to pick what you like.
And do you have scheduled lectures coming up, or?
We have not scheduled the remaining ones, but I'm pretty sure the next one, when we just asked people what they wanted, was going to be something on getting started with image analysis in Python. So we'll talk about things like maybe a little bit more about NumPy and scikit-image. I personally don't have a ton of experience with scikit-learn or TensorFlow or Keras. So I'm not the guy to give you much on machine learning, but I will be talking a little bit more about image analysis, and we don't have that scheduled, but we'll make sure you know about it.
Thank you, sir.
This is Jennifer. I'm working with one of my fellow CZI imaging scientists who's developing a deep learning intro course that we hope to offer in the spring. So please sign up for our listserv if you're not already, if you want to hear about that.
Thank you.
When we schedule it.
Thank you.
Yeah.
A couple stragglers. Any questions among you, or have you walked away from the computer and? Thank you.